Okay, we are now being recorded. So, lesson has started. Yesterday, we talked vocabulary. What word did I get to and say we're going to see this more than anything else? Nope.
Measure.
Nope.
Measurement. Oh, line segment.
Line segment.
Line
segment. Line segment. Which makes sense because today's title, notes, we have line segments, right? So we're going to talk about that a lot today, about actually finding the distance of line segments or the measurement of line segments. So that's how we're going to start with our lesson. Okay, then we'll get to the distance formula. The first thing we got to be able to do is this question right here. This first question is talking about a line segment. Do we see a line segment? No. So we have to, and this is a skill we have to develop in this class, is we have to go and we have to be able to read this and get a picture from it. A lot of times the picture is there, sometimes it's not. So we have to be able to read and draw a picture based on what we read. So it says, find the length of, and what does this mean? Line segment XY, right? This is line segment XY. So we want to find the length of segment XZ. And then we have another key piece. It says if Y is between points X and Z. So that's where we're going to stop reading for a second. And we're going to draw our line segment. So do line segments have arrows or points at the ends? Points. So let's draw a line segment. There's a line segment. Now we're going to label these points. What letters should go on the either end?
X and Y.
Ooh. X and Z. Right? The other letter is Y. How do I know that Y does not go on either end? Yeah, so keyword there says Y is between. And for our purposes, it doesn't matter where Y goes between. We just need to know it goes between somewhere. So that's the first step, right? Notice that this is alphabetical order. That does not always happen. Okay? For these notes, I think it does, but moving forward, this is not always the case. So make sure you read very carefully. All right, now that we have this written correctly, we can start putting these measurements in. It says line segment XY is equal to 3.5. So where can I put 3.5? Yeah, so this portion of our line is 3.5. Then it says YZ is 0.75. So where do I put that? Yeah, right here. Now, looking at our picture now, is that an accurate picture? No, but that's okay. We don't need to erase or adjust or anything. That's fine because the picture gives us an idea of how to solve the problem, right? One thing that we're going to have to get used to this year in geometry is that pictures are deceiving. Pictures are deceiving. And we're going to have to not go by what it looks like, but we're going to have to go by what we are told about it. For example, we're going to see problems this year where we see an angle. It kind of looks like this. Well, what angle does that kind of look like?
Right angle.
Looks like a right angle. But if we have no information about it, can we say for sure it's a right angle? No. So that's one of the tricks we're going to have to learn this year. It's just because it looks one way doesn't mean it is one way, right? We have to be able to prove it, right? And they're going to use some sort of vocabulary word. Probably in this case, it'd be like perpendicular. What does perpendicular mean? Meets at a right angle, right? We'll talk about that in a couple of days. But if we see a vocabulary word that tells us, then we can add that in and we know for sure it's 90. But other than that, if we don't know, we can't assume. So don't just go by it looks like. That's never going to be good enough for geometry. We can't just go it looks like this, okay? All right, now that I'm off that tangent, how do I finish solving this problem? I'm looking for the length of XZ. Bad, very good. 3.5 plus 7.75 is 4.25. Very simple. Okay, how did we know to add? Yeah, they're on the same line. So there's actually a mathematical property that says if you have a line segment the total length of the line segment is just this piece plus this piece put together is the total length. Okay, right now we're not going to worry about what that's called, okay, but it has like an official name. And next chapter, we're going to have to use that official name in what we call a proof. But we're getting a little ahead of ourselves. Okay. For now, all we got to know is 2 little pieces equal a big piece. All right, next problem, and there's a little typo on this one. We're going to cross out that B, and over here we're going to put a C. So it says find the length of BC if B is between points A and C. So our first step is going to be draw that picture. We know we have a line segment. Okay, what letters are on either side? A and C. And we know that B is somewhere in the middle. All right, so that's, again, alphabetical, yes, not always the case. But it's important we know B is in the middle. All right, now we go to the next part. It says AC is 6. So how do I write on here that the length of AC is 6? How can we show that? Yeah, so the way I always do it is I just write a line on top because AC is the whole length, and I just put a 6 up here. So the whole length of that line is 6. And it says line segment AB is 2 3/4. So just by having this picture, this should kind of give us a really good idea of what to do mathematically. How do we find BC? Subtract. BC is going to be 6 minus 2 3/4, which is just 3 1/4. That's it. All right, so if you're a visual person, drawing pictures should probably be priority 1. And that's going to help literally all the way through geometry. If there's no picture, drawing a picture is probably going to help you. All right, so that's easy. Now we're going to ramp up the difficulty a little bit. Same type of problem. Okay, next says find the value of A and line segment XY if Y is between X and Z. So we're going to stop here. We're going to draw our picture. What points are on the outsides? X and Z. What's in the middle? Y. So that's got to be step 1. Make sure those letters are in order. If for some reason you put Z in the middle, you're going to get the whole problem wrong. So you got to make sure you put them in the right spots. All right, now let's label. XY is 3A. XZ is 5A minus 4. So XZ, that's the whole distance. 5A minus 4. YZ is 14. All right, now we've labeled everything. So the goal of this problem is kind of a 2-parter. 1, we want to figure out what A is. Secondly, we want to figure out what is the length of XY. So which one would we have to do first? Find A first, right? Because XY depends on what A is, right? So think about it for a second. Without saying anything, I just want you guys to think. What could we possibly do with this information to figure out what A is? Yes?
I mean, you could always put them on 2 sides of an equation. For instance, 5A minus 4 equals 3A plus 14.
Okay, so Susanna says write an equation. 5A minus 4 is equal to 3A plus 14. Now, how did you know we could do that? That is correct, but how did you know we could do that for sure?
Well, if that's the whole total, then it has to equal the XZ. And if they're 2 sides, you just said you must have them.
Very good. It's the same principle we used up here, right? We talked about up here, this plus this equals the whole thing. Well, nothing changes here, right? 3A plus 14, how do I combine those? Literally put a plus sign between them. 3A plus 14 equals the whole thing, which is 5A minus 4. So that is the new thing we are learning today. This is the geometry part. Going from here to here, that is the new stuff, right? That's what we are learning to do today. So if you can get here, you've got the geometry part. But we're not at the final answer yet. How do we get to the final answer? Now we have to use our what? Algebra. Okay, we should be able to solve an algebraic equation. Subtract 3a on both sides. At the same time, I'm going to go ahead and be fancy and do this. 2a equals 18. Divide by 2, a equals 9. So that part, you should, hopefully, know how to do that, right? The new part is going from that picture to the equation. Are we done yet? No. So another thing to expect and remember about geometry is make sure you know what they are asking for, because this is essentially what all of the problems look like. Almost all year, geometry is some sort of geometry here, and the geometry part is going from a geometry problem to an algebra problem. Okay? The algebra problem helps you solve for a variable. More often than not, a equals 9 is not the correct answer. Because what do they want?
The value of x and y.
They want the length of xy. So how do I figure out the length of xy?
3 times 9.
Yeah, we're going to substitute 9 in for a and get 27. And that would be my final answer. So be very careful when you see problems like these on your homework and especially on the quiz. Because if this problem said solve for xy and it's multiple choice, 27 is the correct answer. What do you think another multiple choice would have been? Yeah, that's going to be sitting there. And they're going to expect you to get to this and go, oh, there's my answer. Even though that's not what they are looking for. So you did all the math correctly, but you didn't find what they want. Somebody's going to get burned by that on Friday on the quiz. I hope it's not you. I hope it's a different period. But so be very careful about what they want you to find. All right. This one. Similar problem. Find x in line segment BC if B is between A and C. So we're going to start with drawing a picture. What are my two endpoints?
A and C.
A and C. B is in the middle somewhere. And then we can label. So it says AC is equal to 4x minus 12. AB is x. BC is 2x plus 3. And I want you guys to keep going on your own. Give you about 30, 45 seconds. We've got the setup. Know what the problem looks like. Can you figure out what happens next? All right, let me pause. We have to set up an equation, right? If we're following the pattern of the problem, right? We got to set up an equation. Okay? Tell me if this is logical or not. Can I do 4x minus 12 equals 2x plus 3?
No.
Why does this not make logical sense? Because I've got a whole piece equals part of a piece. Does that work?
No.
No. So I've got to figure out some way to combine these two together. So keep going. See if you made that mistake. See if you can't figure out how to correct that mistake. So what is it looking for? You have the right idea. Just like this. Well, you could start by writing down what's there.
I think that was wrong.
It's not, it's wrong right now, we can add something to it. So, a lot of us have it already. 4x minus 12, that's the big piece, right? That's this. Okay, all together, that is the big piece. If I want to figure out what's equal to that piece, what do I got to do with these pieces, Brady?
You gotta add them.
Add them together. So how can I add these two together? Add it, right? Use addition. So we can't leave it at 2x plus 3 because that's only part of it. But if I just add in the x, now it works because now we have both pieces equals the big piece. So that's the one change that this mistake needed to make, right? Because now we combine like terms. 4x minus 12 equals 3x plus 3. And now we can solve an equation, right? So going from here to here, that's the new, right? Going from here to x equals 15, that's the old, okay? Am I done with the problem? No, because we also need to find what BC is equal to. So what do I do with this 15? Substitute it, very good. 2 times 15 plus 3. BC is equal to 33. Questions, concerns, comments? Okay, so that's one type of problem that we need to talk about today is just line segment problems. We'll see some more of these tomorrow using some new vocabulary. Okay, now we need to talk about the distance formula. It's not that scary. Looks much scarier than it actually is.
No, it looks very scary.
Okay, this is the distance formula. Okay, first let me say you do not need to memorize this.
Yay.
Okay, this will be given to you anytime you need it. This is a poster that will go on the back wall when you guys leave. So during my conference, I will staple this to the wall, and it will be on the back wall the entire school year. It will never, ever be covered up. Okay, so you do not need to memorize it, you just need to know how to use it. Okay, so we have D stands for distance. So the distance, and then we have square root x2 minus x1 squared plus y2 minus y1 squared. Where do those x's and y's come from?
Points.
Points, which makes sense because the distance formula is used to find how far apart are these 2 points, right? So now we are talking about graphs. So if we look down here at this picture, right, essentially what we're doing is we're taking 2 points and we're saying, okay, how far apart are these 2 points, right? We can't count them. That doesn't work. Nope, that doesn't work either. That's slope. We want to find the distance. Okay, so we're going to use the distance formula. The first step I would highly suggest you do, it's what I do when I make a key for this type of problem, is I label these points. This is x1, that's y1. This is x2, this is y2. I think labeling is super useful because now you know exactly which number goes where. And that's really most of the battle in distance formula. Can you put the numbers in the right spots? So let's see. Distance equals, we're going to draw a big old square root. We're going to start with the parentheses. And then looking at the formula, what term is going to come first?
Negative 4.
No.
Minus
Negative
5.
one. I mean 5.
Look here.
It's 5. 5.
Negative 5.
So the next day. No, just 5.
Just positive 5, right? So we're going to take this number 5 and we're going to plug it in right there. So it's just 5.
Yeah.
All right. Then there's a minus sign. What goes next? Yeah, this negative 4 is going to go next. So we're going to write negative 4. So we have 5 minus negative 4. Don't forget the square. Don't forget the plus. That's part of the formula. Then parentheses. Now we're going to do the y values. Negative 1 minus negative 6 squared. Now, whenever we have double negatives like this, or minus a negative, sometimes I like to put parentheses around them. You don't have to do that, but for some people it's more organized. If you had a calculator right now, you could type all this in the calculator and get an answer.
But we don't.
Yes, Bryson?
Do we have the calculators on Friday?
We do not. So instead, we're going to simplify it. So on the next step, we're going to go from this big long radical to a small one. All we're going to do, and again, be careful, 5 minus negative 4 equals 9. So this is 9 squared plus, good, negative 1 minus negative 6 is 5. So we have 9 squared plus 5 squared. Is that much more simplified? Yes. And now we keep simplifying. 81 plus 25. 9 squared, 9 times 9, 81. 5 squared, 5 times 5, 25. And then we add them together, get 106.
Can that be simplified further?
Good. So the next thing we check, right? We just practice this unit 0. Since we're not done with a calculator, we would want to check, does this have any factor pairs? And the answer is no, it does not. So this is the final answer. If you had a calculator, you could type this in and you would get 10.2942081411162, blah, 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 blah. Right? So I'm guessing. I know the first two numbers and that's it. Okay. But we would have to round that to 10.3, which is not a completely accurate number. It's a good approximation, but not completely accurate. Right? So if you had a calculator, that's all you would have to do. Get here, plug that into the calculator, got your answer. All right, next problem. I'm going to label these points for you, and then I want you guys to finish the problem. Ready, go.
Bless you. Thank you.
All right, hopefully at least we got this part correct, plugging in the problem correctly. Can't do that? I don't know. You probably in trouble for this year. You can't plug in numbers, right spots. Okay. Now the next step, mistakes can happen because we don't have a calculator, which is good. You guys know the reason I don't let you guys, I'm kind of withholding the calculators right now. It's because Algebra 2 withholds the calculators. On open house night, I had several sophomores I had in my class last year come in and tell me how hard Algebra 2 was because their teacher wasn't letting them use a calculator. So I'm trying to help prepare you guys for that. So I will let you have it at some points, but for now, we can do all this by hand. All right, so mistakes can happen here. -3 minus 2 is -5 squared. -2 minus 4 is -6 squared. So there might have been a couple of mistakes there with the negatives. All right, then -5 squared is, positive 25 and then positive 36. Remember, negative times a negative should be a positive. And then we get 61. This one has no factor pairs, so that's it. Final answer. All right. So, now, I kind of want to pose this question to you. Where in the world did the distance formula come from? Who discovered how that formula came about? So, let's take a look at the graph and see if we can't figure it out. So, we will see some problems on our homework and on our quiz where they just give us 2 points and say, what's the distance, right? We just worked those. We will also see where they give us a graph with a bunch of points on it, and they just say, okay, find the distance between those 2 points, specifically B and D. So we're talking about this distance. We want to know how long exactly is that line segment. Is counting an option here? No, you can't count vertical or diagonal lines, just vertical and horizontal. Now, we could get the ordered pairs here. This is -4, 4, and D is 4, -2. And we could do the exact same thing we just did. We could put them in the distance formula, and we will get the correct answer, as long as we put it in correctly. But I want to talk about what the distance formula is actually doing. Okay, let's take a look at the x values. X values go which way on a graph? They go horizontal, left and right, right? So when I am doing x2 minus x1, we are actually figuring out how far apart horizontally, right, is D from B, right? We're finding this distance. Well, on a graph, can we count how far apart they are? Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Right, and then the y2 minus y1 is counting how far apart they are vertically. So 1, 2, 3, 4, 5, 6. And when you look at a graph like this, now what does this kind of look like?
Triangle.
Specifically what kind?
Right triangle.
Before we get there, we need to see that it is a right triangle. In right triangles, we can use Pythagorean theorem, which is?
A squared plus B squared equals C squared.
Good. Now we have A and B. These are my two legs. We're looking for C. So we can just go 6 squared plus 8 squared equals C squared, which is 36 plus 64 equals C squared, which is 100 equals C squared. C is 10, which means line segment BD is 10. So why does Pythagorean theorem work in a distance formula problem? It's because the distance formula is the Pythagorean theorem. Look back up here. When I do x squared minus x, or x2 minus x1 squared, that's just a squared. Plus, when I do y2 minus y1, that's just b squared. Over here, d is actually c. And if I work backwards and square both sides, the radical goes away, and we just have c squared. So the distance formula is just the Pythagorean theorem. That's where it came from. It's the Pythagorean theorem that you can use without actually seeing the right triangle. But if we have a graph, we might as well use Pythagorean theorem instead of the distance formula. But if you feel like the distance formula is just easier, you are free to use that one as well. All right, so let's do H and A. So here's H, here's A. There's the distance between them. That's what we're looking for. We can draw a right triangle. We can see that this leg is 3, this leg is 7. And we are looking for the hypotenuse, aka the longest side, aka the diagonal. 3 squared plus 7 squared equals c squared, which is 9 plus 49 squared.
Oh, my bad.
Which is 58 equals c squared. Square root of both sides. And c is equal to the square root of 58. And we can't simplify it, so that's the answer. Now would be a great time to ask questions if you're kind of lost. Nobody? Going once, going twice? All right, and the last one, the distance between F and J. This is actually the easiest one of the whole page. How far apart are F and J? Yeah. Vertical and horizontal lines, you can just count the distance. You don't need anything special. All right, now, hold on. Before we start moving around, we're talking, I should say. Could I have, for these problems, used the distance formula?
Yes.
Yes. Could I have, for these two problems up here, could I have used the Pythagorean theorem?
Yes.
Yes, but you would need what? You would need a graph. So you can use either strategy for either problem, but this one requires you to have graph paper or be good at drawing graphs, right? This one just requires the distance formula. All right.